Hey guys, so these videos are best played at 1.25 speed. This is a little bit on kinetic energy. We're going to get into it again with this roller coaster picture, and we're actually going to use the same numbers that we had used in the past. So what I did was I set up my roller coaster here, and I gave it a height of 10 meters. I gave this a mass of 100 kilograms. And I gave, well, I didn't give gravity. We know what gravity is. So what I've done here is I've used the same picture so I can tell you and show you what something called kinetic energy is. Okay, so I'm just going to write down a little definition here for you. Kinetic energy is the energy of motion. Okay, that's all nice. It's nice to know what it is. It's the energy of motion. So at this point, this cart up in the very top, if it's not moving, does not have any kinetic energy. Okay, so let's talk about what happens when I let the cart go. Okay, so if I let the cart go, it's going to go down the hill, and we know that at this point right here, okay, it's going to be moving the fastest at the very bottom of this track here. At the very bottom of the track, it's going to be moving the fastest. So look, I've got gravitational potential energy, which is stored energy here. I've released it, and now it's transferred or even transformed into what we call kinetic energy at the bottom. So now we know this is energy of motion, but how do we find out how much kinetic energy it does indeed have? Well, I'm here to tell you that it's actually pretty simple to find out how much kinetic energy it has. So look, does this have any height anymore? The answer is no. So if it doesn't have any more height, does it have any more gravitational potential energy? The answer is no. So gravitational potential energy now transformed into what we call kinetic energy. Okay, the energy of motion. And I put a little equal sign in here because at this point, in a perfect situation with no friction and no air resistance, the kinetic energy at the bottom equals the potential energy at top. Okay, so whatever potential energy we had up here, and I think we had 9,800 joules of energy at the top, the kinetic energy now is equal to 9,800 joules. So here's the deal. I gave it energy to start with. I gave it 9,800 joules. It's gone down the roller coaster. It's lost potential and gained kinetic. And now it's got all kinetic and no potential. So another way we could actually write this is, I'm going to try to fit it in over here. The gravitational potential energy, GPE, at the top of the hill is 100%. The kinetic energy at the top of the hill is 0%. It's not moving. Now, it does a little flip-flop here. Okay, at the bottom of the hill, potential energy is 0%. Kinetic energy is now 100%. Now, this kind of falls in line with our conservation principles. Remember when I said conservation principles mean that energy is not lost, it's just transferred? Well, look, it actually transfers from all gravitational to all kinetic at the bottom of the hill, which I think is pretty cool. Now, how do we solve for kinetic energy? Well, I'm not going to let this video go too much longer than 10 minutes. Let's actually give you the formula for it, which you probably found in the notes. Kinetic energy is half mv squared. So in order to calculate the kinetic energy, you've got to have the mass of the item and the velocity of the item. So In this case, I'm actually given the kinetic energy already. So I could solve for the velocity of the item at the bottom. So I'm going to go take the last 5 minutes or so of the video to have an overview of this, maybe give you an example or two to look at. Okay, so remember, the top of the hill, it's all potential. The bottom of the hill, it's all kinetic. Now, if you wanted to look at it in terms of like halfway through, or even like right here, we can say that the kinetic energy, KE, is right here, 50%, and the potential energy is 50%. Okay, I put a little G in front of there. So at halfway point, it's 50. So again, potential energy is 50%, and kinetic energy is 50%. Okay, at the middle of the hill, because I've got half the height, and it's only going half the speed here as well. So let's take a look at how we solve for some of these actual numbers. Might want to pause it and just draw the picture there. So we had a formula here that said kinetic energy is half times the mass times the velocity squared. All right, well, okay. Now the roller coaster problem, okay, it said we had the kinetic energy because it was equivalent to the potential at the top, and we said it was 9,800 joules. Remember the mass of that cart? The mass was 100 kilograms. So look, I've got this, so I should be able to solve for what the velocity is of that cart at the bottom of the hill. And that's a pretty cool thing. I'll tell you, to be able to get the velocity of the cart at the bottom of the hill is kind of an important thing to get, especially if you're a, I don't know, maybe a roller coaster builder or something like that. So look, I'm given the kinetic energy, I'm given the mass, I got to get velocity. So let's just do a simple rearranging of the formula. And you guys, by this point, you should be able to switch back and forth between formulas, or you could actually keep it the way it is and just solve for the V. Personally, I like to solve for V to get it all by itself. So I'm going to divide through by a half M. So I divided through by a half M. So KE over half M equals V squared. Okay, I know some of you guys probably don't like that half down there. I know it's it doesn't seem all that nice when you're doing the math. So anything divided by half is the same thing as multiplying by 2. So this actually is 2KE over M. Now I don't want to get V squared by itself. I want to get, I'll bring it up here. So V squared is 2KE over M. Now what I want to do is I want to get rid of the square. And you remember when we look back at problems like this, to get rid of a square, we square root it. V is the square root of 2 times the kinetic energy over the mass. I know that was kind of long-winded, and you probably could just plug in these numbers here for mass and kinetic energy and still come up with the velocity. But here's my rendition where we take it and we solve for V. So look, so 2 kinetic energy is 9,800. The mass was 100. So in doing the math here, I ended up getting the velocity is the square root of 196. And the square root of 196 is 14. So I know we went pretty quickly through that, and I'm trying to keep under 10 minutes here in the videos. But I solved for V, given the fact I had kinetic energy and mass, and I could get V. Now, you could also have to solve for M, And excuse me, in the simpler part, you could also have to solve for kinetic energy. Now, in the homework problems, you're going to have a couple questions like that, where you have to solve for velocity and then where you have to solve for mass too. Okay, I'll always give you 2 out of the 3 variables, so you should be able to get that. All right, so that'll do it now for kinetic energy. You do need to do a little practice, I'm sure, and please ask questions if you have them, and we'll talk to you later.